All right, welcome everyone at the next multi-networking community sync. Today is February 21st, and today we want to talk about last week's SIG networking feedback that we kind of start talking about. We brought up kind of the feasibility of multi-networking to the SIG networking, and yeah, let's talk about it in a second. And then one of the feedbacks was to kind of maybe create use cases that are not so solution oriented. I think that's would be good proper discussion, but maybe let's step back to the feedback. So I think I'm taking it as a positive from the feedback. Like before I was hearing like, no, let's just disable, let's not do it at all this time. I think let's compare nodes. Let's see. I think the main problem would be with the problem. Trying to see what's is there any overlap with all the other efforts, and namely the KNI and the DRA with multi-networking, right? And basically pick and choose the better approach to do this. And thanks to Michael Zappa, we are working to he kind of initiated discussion on this between us, and I think KNI and multi-networking are completely just complementary things, and this is basically defined in our even in the CAP itself, where basically we are just providing some information on what the CRIs can do, and with KNI is just we are not doing this in CRI. We'll have to slightly modify the kubelet side, and that's it. So we would pass the networks, pod networks, to the KNI, and that will have to handle whatever we do. So that part is kind of there is no overlap between us. But the other thing was DRA. And Michael, I think we started some chat discussion. I'm kind of seeing it, and I'm not sure what's your feeling about that one. We have some discussion with Patrick so that everyone in the room knows. And basically, that he did mention that he wants to enable networks interfaces into the pod with DRA. And this is where we need to probably get some details of what level of that he's thinking of versus what we are doing, right? So I think there might be some proper division, and I think that's what's missing is the definition. Yes, Michael, go ahead.
Yeah, I was gonna say from the how I read the conversation with the DRA is that we have our calico flannel and whatever set up today. It didn't sound like that was their scope. It sounded specifically around like GPU and like NVIDIA Mellanox cards, like additional interfaces inside the pod network namespace and the allocation of it. So it didn't particularly seem, like there were some areas that they weren't solving, which is probably good to call out. Like that's not an area versus SRIV. In this case, those could help multi-network from my perspective.
So and I agree. So basically, what I think the division can be like the between the two is that DRA is like device plugin. It's an enhanced. I see it as a enhanced device plugin, right? Which much more advanced ways to do stuff. Slice and dice the device the way you wish, and basically provide you just more sophisticated version of the device plugin. And even we do today with the for the SROV stuff, we rely on the device plugin to just give me a one VF or two VFs or what's not. And then the networking, on that other hand, is the one that, if need be, to define the IPAM story, the routing story inside the pod, if need be, of course. So this is where maybe the bit of an overlap would be if you think about the what we call a DPDK type or user space type of interfaces for SROV, where basically the SROV CNI just does nothing, right, at that point. Because if you pass a device that's just a VFIO bound interface, so basically there is no net device, there SRO VCNI does nothing. Yes, Pete.
Yeah, I was just going to comment that one of the pain points for us with multi-network at the moment is the fact that you have to use the device plugin to get some kind of device into the pod,
Yeah.
and then you have to do networking, and those two are not very joined up at the moment. And there's a pay that if I don't see how we could do it, but if we could make those two be more joined up, that would be a big selling point for people who are currently having to have device plugins write files that are picked up by CNI plugins and stuff like that.
Yeah, and I agree because this is so when you think about this from let's think about the AI use case. This is where I'm not so confirmed, but I'm not sure how folks here are familiar with RDMA, because I think this is where the AI folks are mostly going to use it. But if I'm not mistaken, RDMA still does require some net device to be present, right? So you would need some IP, and you will need something to have inside your pod to set up the RDMA. Can someone confirm? I'm not sure. Do we have any RDMA specialist here that could confirm that, or anyone? I don't think so. Okay, so we will just rely on my vague understanding. So for AI ML, even if you were to just pass in the interface as is, I'm not sure whether they can do that without the CNI, unless I think Patrick was saying DRA introduces some sort of additional plugins to the CRI. So that's another layer that I was completely missing on. That beside having the controller that can slice and dice your devices and exposes that to the API, then there is a part of the kubelet or CRI plugin where then that device is then properly handled. Like this is a daemon that basically handles the way you need it to be handled on the node. So let's assume it's a FPGA that has its own ways to be configured or exposed or what's not, and basically that plugin will be able to and will know how to do that for you, right? So basically there is no common, they don't expect any commonality across devices, where CNI expects the net device basically. In this case, sky's the limit. It's flexibility and you can do whatever, and that's what they expect. But I don't think they want to go. I wonder whether they want to go into the story of IPAM and routing at this point, right? So this is something that probably would have to clear out the kind of details on that, and if that's even needed for them, right? Because I think we need to make sure that multi-network can be relevant for the AI ML use case, because that's what everyone's talking about. This is what Kubernetes is going to mostly focus on, and this is where the Kubernetes will be willing to pay the complexity to support, right? So this is something that we need to ensure that we can work out with the DRA to where is the exact kind of division of responsibilities between the two APIs, right? So that's kind of my taking. Any other comments from the feedback in itself from last Thursday?
One thing that struck me, separate to this whole we should be working together with other groups, is the feedback we got from mostly Antonio. And I would summarize that as there's a whole bunch of areas where multi-network might have big impacts, and we should be very precise about it. So an example of that is he mentioned DNS. Now, I don't think we're planning to do anything very much with DNS in multi-network, but just being explicit about all the places where there's networking and we're not going to change this, or this is the thing we might have to change. Because I think there's a nervousness that multi-network will turn the world upside down in ways that I don't think it will. But if we could finish off the nervousness by being as explicit as possible, I think that'll make it an easier sell.
So that's fair. And I think, to be honest, if you think about supporting services, you have to think about DNS. That's like comes in pair, Pete. So I think that's why he's bringing this up, right? The one thing in terms of DNS is not part of core Kubernetes. You have kubedns or core DNS. There are two separate things, and you have just the service DNS, which is on point 10, and it just assumed one IP that everyone's using. But core itself, I don't think that it's just, you don't expose anything. Core does not support DNS at all. So, and that's good for us because basically sky's the limit. If you want to have DNS with you, that's good. So we would not have to change anything in the core to support it. So I'm considering DNS. Yes, it is a complex thing, but it's nothing in regards to the multi-networking effort, because in our case, we would just say, what are the pitfalls, what can be handled, and probably we wouldn't have to do anything. We will maybe just enable things to do one way or the other, but beside that, however CNI configures DNS, it's up to the CNI implementation, and it will be up to the operator of the cluster itself on how the DNSs are handled. And as we talked about this, I mentioned this, some of those use cases last week where you have multi-homing versus multi-tenancy, right? So there are the two kind of cases that here's handled. Michael, sorry, yeah, go ahead.
I was going to say that, yeah, one of the concerns was DNS. However, we also have to have the user story to say, my second network needs to have DNS, or maybe they don't need DNS. So I think that was part of just to this other bullet point that we're going to discuss, is that we probably should have that solidified.
Yeah.
As a customer centric user story.
Yeah, and that's fair. That's exactly what yeah. But I think, Pete, I think I do have a use case for the DNS support, but I don't think it would touch core. That's my thinking about this. That I have to kind of slice and dice something in the core to get it supported, right? Because I consider DNS to be completely independent capability that is not so much tied into core in any way. At least that's my thinking about it. Unless someone can kind of correct me about this, but I don't think there is anything in core that kind of says pod has the additional extra config for resolve conf that you can pull in. If not, then I think the DNS service is being used as the next hop, and that's it, right? So maybe this will be one contention point where for each network, separate networks, depending on which one is primary, I want to make that services IP to be the the one that will override the DNS, right? So maybe that one aspect would be of this, because I think the resolve conf is set up by kubelet. Can someone confirm who's setting up the resolve conf inside the pod?
So in particular, the DNS config object is part of SyncPod when they create the sandbox config, and that's passed down to the run pod sandbox CRI API for runtime service.
So CRI is the owner of this.
Well, the kubelet is. The kubelet passes it down to the container runtime.
Because pods, I know inside the pod spec you have some extra configuration, right? You can do some additional use the host.
You can have, well, I guess it's in two places, because you can have DNS policy where you actually can explicitly pick your DNS, your name servers.
Yeah.
And you can also have the CNI. So, it's kind of, where I can put some links really quick from the kubelet perspective and container runtime.
But basically, this is where I would say it's nothing breakthrough that will going to do that for you. And the one thing maybe we need to call out, that I would say that multi-network could be an opt-in feature, and it should always be opt-in. And then we are just a feature that if someone really needs it, then enables it and has it, right? Otherwise, you don't have it. I'm not sure. That's definitely will. I think that was Pete. You were saying that. I think last time we talked, or someone was saying that exactly, to just have the flag always there, right? Even if when we GA, the flag will be always there. And basically same like with, I don't know, there is a topology manager you enable and then sets up a different combination of it. And basically multi-network would be that aspect as well, right? We just define how that behaves. You enable it, you cannot disable it, it's always there. So you have to make a kind of a conscious decision about enabling it. Yeah, Doug.
I like the idea of this because I think that one of the items of feedback that we get now and again is that it's a minority of clusters that need this functionality. So I like the idea of that. The thing that I think would be disappointing is if it wasn't easily achievable as a day 2 operation. Like if you need to like drain nodes and like restart kubelets and stuff like that, I think that would be a bummer.
Yeah.
But yeah, that's my thoughts on it.
Yeah, that's exactly right. So, but how you would enable it on the cluster? Is it only for new clusters, or can you migrate? How would that look like? Yeah, I think that's another thing that's kind of we need to look at it right here. But I think that's just yeah, basically those are the various ways on how we kind of guard this. But I wonder whether that's even an option. I'm not sure whether that's a pattern in Kubernetes. Can you enable a feature as just to be all? Is there a feature that is always like behind the flag? Anyone is aware? Except for like configuration of like enumerate, so I can have this or that. But is there a feature which is completely enabled or disabled, and you still like that?
Isn't the CSI behind a feature flag, or am I crazy? Part of the kubelet config. I can check. I'm sure there is. I mean, it would make sense that everything shouldn't just be on.
Mm-hmm. All right. So yeah, we will see what can be done with about that. We will just basically maybe just I will have to update probably the cap to kind of point that out that we can be. Oh, I hope I did. I probably didn't update the current version to say that, but there is that. So on that note as well, going back to the kind of use cases as well, because that was another feedback from Thursday, that our use cases are kind of solutions rather than just like really use cases. So I would want to discuss about that in a second. But before that, apparently Antonio's set up a workshop in EU KubeCon. And my question is to this group, is anyone planning to attend EU KubeCon and will be willing to represent this community there? Ooh, nobody?
Well,
Okay, so
I'm gonna be there, and I'm happy to represent what's necessary in
oh, that's awesome, Doc. Okay, so you okay, there you go. So great, that's
Also,
perfect.
also trying to be there, but still negotiating eventual tickets. So
Okay.
depends.
Okay, so that's great. So having said that, so we have representative, that's awesome. So that would be great. What I think the KubeCon is in 2 weeks or so. What we need to do is create a solid use cases so that Doug and Nathan can have ammo to do that, right? Because I think the current use cases, some of them are not exactly like real life use cases that you would think of that someone would use. Maybe you definitely have the telco one, but even there, I think we need to, I know the use cases for telco from whatever the telecom requested from us, and maybe that's not how we should look at it, unless you correct me, unless you can get me wrong, you can correct me. But yeah, let's talk about the use cases. But before we do that, any other comments on the Thursday, the feedback? If not, then let's jump to that. Just want to know that I sent out to the SIG networking the note on the cap itself, so I get some comments on the design. If someone wants to kind of help out with the replies to this, please feel free. I haven't had a chance to kind of go through them yet, but some of the folks started reading the design and giving some feedback. So leaving comments. So I'm gonna kind of start. So there is some movement on the cap. That's kind of what to kind of point out. If you want to kind of start as well, commenting on that. So the use cases. So what I was thinking is to create the use case, like let's say the AI ML use case, right? And the use case for AI ML that I initially that I'm aware of is I want to run my train my models in a pod. That's basically the top level, right? And for that reason, I have to have I am able to redistribute my workloads, my training, and I need to have a fast, low latency communication between those workloads. I think, if not mistaken, that is the very top level of the use case. And this is a use case where we don't specify any solution for it. I think this is the form that we should have our use cases defined as. Any comment? Michael, yeah, go ahead, you had a hand.
Yeah, well, for like the overall user story for like AI and ML, and from what I've heard, that I don't know what the persona would protect particular be here. However, a lot of companies seem to be needing access to other people's cloud, like their L2 segments, so the VPC, the VNet, whatever you want to call it. So from a non-technical perspective, you could phrase it that way, that multi as a user of like A or ML, I need the ability to access other customer L2 segments, and I'm saying L2 segment just because VNet VPC may be too technical, so that I can build my data sets with us various customers. So that does seem to be actually a tangible one that I've heard multiple people talk about.
Mm-hmm. Any other comments to this? And what do you think about this kind of type of description of the use cases rather than just what we currently have? Any comments on that? I think that will then provide basically what the user wants rather than what we think the solution can be for those use cases.
Are you asking about like bucketing these? So yeah, you have your AI ML bucket, your whatever bucket, and then your next bucket, and
So
then
not even buckets. I would like to call out the use cases, the real life use cases that we want to cover, right? Like what we have today in the cap is rather kind of solutions that you can do right between. So you can have your vSwitch, you can have your bridge, but why, right? Why you do it this way, not the other, right? So rather than just provide the solutions, let's provide the use case. And now let's talk about the telecom, right? Use case, telecom. What is the requirement here? What is the use case, right? Because I keep bringing up the I think my first why we want to have the other interface for this is and get me, is it because we have to have a fast performance, and is it high bandwidth, low latency a requirement as well for the specific workload? Let's think UPF. So the user plane function, right? So the main one that basically does the NATing from user devices to the internet, right? To the IPs. That one, could that be done? And maybe other I will ask it differently. Could that be done with a single interface in that pod? We have some, I think some folks over here are some telecom that, right?
I would say anything that doesn't require, and this is just generic, that doesn't require separate routing tables and that you really keep things apart can be done with one interface. It doesn't really matter what it is. You can, I mean, not saying that today's Kubernetes maybe has the performance over the ETH0 network, but I mean, that can always be fixed. So when it comes to performance, I don't think it is as much a single home or multi-homed. That has more to do with separation. I mean, true separations, firewalling between, call it the packet flows and so on, that and different routing tables. So
so how would we? So you say the high performance and low latency is not an aspect? I would say it is, right?
I'm saying that I'm saying that in today's Kubernetes is absolutely is, where you have the kube proxy sitting in between and so on, and that we're talking many milliseconds before a packet gets up into the pod after it had reached the interface. But I can see other implementations that doesn't have those problems, and so saying that, so basically say I agree with you that is a problem, but I don't know if. And it's possible to solve it by adding a different network today and using, I mean, directly tie on a port that, or SRIOV, or having a smart, I mean, some sort of accelerated card there in between, right? And even push down works on the accelerated card. That's probably the most straightforward way to do it today. But I wouldn't say that's the only way to doing it. You could fix so that the primary networking is much more performant as well.
Yeah, exactly. That's what I'm trying to get to. So if I would, let's go to the imaginary world. Let's on this one, let's go to the imaginary world, and let's say my default interface is done through some user space thingy, DPDK, OVS, something that supports the whole Kubernetes. So it can do services, it can do nothing, what the features. Let's assume that's the case. And as well, it has low latency and high performance. Let's say this is Magical World and it can do that. Would that be would that satisfy telecom, right? That's, I think that's my question.
For everything, no, because you have things where you really want to have it on separate interfaces for security domains and other things. Maybe can you do that on if you would have tunnels coming in? Yeah, you could probably tunnel it over.
Yeah, that's so let's
if I look at something like a 5G user plane, right? I mean, today you have a GTP tunnel on one side and you have the internet on another side, and then typically you might want to, from that gateway, push the packets to a firewall that's not in the gateway, and then out from there, right? So you could do things with explicit overlays and so on at that level, but typically to have the pod becoming the endpoint, yeah.
And if we have to go through hoops of, like you said, tunneling, let's call it out as a requirement that we have to have segregation. And basically how you do it, that's I think that's secondary, but then basically this is a problem, right? Then that we have to have ability to separate the types of traffic that I generate in a pod or the pod receives, right?
So typically those two endpoints, and this is why you want to have different VRFs, but could probably do, because you have different routing tables on those two sides, very different. On one side is the internet. On the other side,
Mm.
it's sort of the
Internal, yeah.
the terminals, right, and how to get to them. So
Yeah.
that requires VRFs, and VRFs support. Does it require that you have a physical interface tied to that VRF, or it could be a tunnel interface that comes in over the other one?
And sorry for interrupting, but maybe another use case is related to the telecom. Peter Byrne speaking from Nokia side that, for example, if there are overlapping IPs, which is in telecommunication, this is a very common use case.
The VRF can handle that.
Yeah, the VRF says, but what with the single interface we can't handle this.
Exactly. No, exactly. I mean, if you want your physical interface to have different routing tables, then definitely you need different physical interfaces, and it could also be from performance, right? I mean, if you have 100 gig, depending on how much you can do, that you might need to have different interfaces just to handle more workload than one interface can give. And you don't want to use things like lags and so on. So
Overlapping IPs, I think Doug, you have the hand. Go ahead.
Cool. On a few things. I mean, what Pear is bringing up with VRFs and overlapping IPs, I feel like this is a missing part of the puzzle, and I'm gonna write it down for now just because I think that's a valid thing. But
it wasn't me that brought up the overlapping addresses, but that's implied by.
Sorry, Pear. I didn't.
I'm Peter, so it's very similar name. Yeah.
So
I brought up VRFs, but we're on the same page.
So VRFs is I would call out, and correct me if I'm wrong, VRFs would be a solution to the problem. And let's not call out solution. So basically the requirement would be overlapping IPs. Are we agree on that? Is that fair?
So overlapping IPs is one thing, but it's different routing tables and overlapping IPs.
Oh, so basically,
but basically you have different routing domains. And if you go back to, I guess we'll have the discussion again when we do the plumbing group. We discussed that a lot, sort of how to be able to tie a network to call it a IP domain. So you would understand that it's part of an address scope with its routing tables, and that two different networks can be two different domains, and thereby can have different basically overlapping addresses.
Pete, you have a hand.
Yeah, and the other use case that I have in my mind is that you let's say you have two networks, you have two physical networks, and you have something that has to act as a gateway or a router or an SBC between them, and it has to be able to run at line rate in both networks. You can imagine ways in which you could take some of that function out of the pod, put it somewhere else, and then simplify the networking in the pod. But all you're doing is taking that router application you've got that's doing DPDK on multiple interfaces at once and saying, well, you can't run that in Kubernetes, to my mind. It feels like there are things you could do, but they're much, much more complicated than just saying, well, put two interfaces, two SRIO VFs into the same pod on the two different interfaces and let the pod handle both of them.
So Pete, I think this could be another use case. Can we get back to that? Let's maybe, I would like to kind of drill down to the telecom, unless it is related to that. Are you seeing it?
This is absolutely telecom. This is session border controllers. So you've got UPFs and 5G networks. Both of them fall into that category.
Got you. Basically, because this is, I see. You're right. But okay.
And SBC is logically just a router for telephony calls, and similarly, UPF is really just a router for 5G data plane. So it's kind of the same logic.
I think I'm gonna keep Michael. You were next. Go ahead. Unless you
there we go. Sorry. I was going to say, if we were going to drill down into the specifics, like say as overlapping IP addresses, for example, to make an actual user focused user story, it's kind of like, who needs the overlapping IP addresses? Why does the workload need that? Why do we need the overlapping, IP addresses? What are we trying to accomplish? And what is the measurable impact to said persona? So that's how we would make like an actual customer focused user story. So these are like, still solutions to the problem. If we were to drill down to like, why do I need that? Who needs that? And what is the impact? Then we can actually come up with like, tangible user stories.
And that's what I want to achieve. And thank you, Mark. Yeah, let's make sure we keep to that. So I think Peter, you were next. You're muted if you're speaking.
Sorry, I double mute. Sorry, what I want, the additional things what I wanted to mention next to this overlapping IP is that, and what is can be the use case is the slicing. That because if you're speaking about the slicing, there this should be separated. There should be guaranteed QoS and this type of things, and there can be overlapping IP. So and these are
With slicing, you mean the 5G interfaces, or you mean something else?
yeah.
Okay.
And for example, if you're speaking
Support-
about the
so-
UPF case, the N6 end of the UPF, yeah, for example.
So at the next plumbing group meeting, I can show a couple of slides that shows how we're implementing all this at Kaloom with the VRFs in pods and routing and all that stuff.
So I would like, Peter, this is what Michael was referring to, right? Let's try focusing on the requirements and basically the use case rather than the solution, because I think we are again going into the solution of the thing.
I can say what the requirement is by showing a couple of pictures, but I can do that not at this meeting. I can do it at the plumbing group.
Okay. Sure. I think there was, I'm not sure, Per you were speaking, so Doug?
I just wanted to go, I put this in chat as well, but I wanted to make the point that I kind of think that a lot of the like telco challenges that we're already familiar with actually apply in the AI/ML space, especially on the hardware front. Like we know it's challenging. And then I just think that there's something fundamentally different about them culturally as well, which is telcos are gonna have legacy stuff that's gonna be difficult to change. That's like kind of a more delicate ecosystem. I think that AIML
It's a mass produce. It's a mass produce. If someone fails, I'm gonna create another one, and I don't care about reliability. I agree with you. That's completely different story.
Right. So there's that, but I do think it's important to note this hardware overlap. We're gonna run into that in both places, and I think it's a core part of it.
And yeah, that's a fair point. And this is where I think the problem we need to push for is to ensure that I think our use cases are more strict, I would say, multi-networking in terms of like at least the telecom, right? It's more strict in what we need to achieve. And we need to have as well more flexibility on configuration. Whereas for for AI/ML, I need an interface. I don't care about the IP. Just need to connect one to one with the other and whatever. And just if they work, I don't care about anything else, right? I don't even think about like, oh, routing inside the pod. What's that, right? I think that's the approach the AI/ML folks have, and that's kind of unfortunate that. Yeah, then it's easy, right? Because then you don't have to worry about anything, and then you don't have to need why do you need those routing configuration or those additional stuff and just overcomplicate things. But that's where we need to make sure that we can handle not just one use case, but with this we can handle some other use cases as well and support them, especially when our current approach doesn't even like explicitly say I want to have routes or I want to have this IP or that. It's just it's left outside of core anyway. So I think the way we have it, it's really kind of clean to do this. But yeah, any other comments on the telecom? So I think from what Michael said, the one real use case is and one thing is the slicing capability, right? And network isolation. The routing domains and overlapping IPs. This is just a solution to the slicing, and then isolation is something that you cannot deal with because and I assume network isolation, it will be for for government compliance. Is that correct, or there is some other approach for that?
There's also there's other things that you might use it for. Notably for me is at least one case I've had before is for UDP traffic for media. Like you don't want to mix the streams there. Because of UDP contention. So like on like
Oh,
typical telephony network, you'd isolate signal, media, and management, not because of the government requires you to, but because it's a nicer layout. And yeah, and it ensures that you always have that capacity on your management network.
yeah. Per?
Can someone, this is support for slicing, can we just say 5G slicing? Because slicing can be many things.
I'm not familiar. Yes, please.
It's very specific for
yeah.
3GPP and 5G, this sort of implementation.
Yeah, please, Doug. Nathan?
On network isolation, maybe it's worth differentiating it from policies, and seeing that sometimes you need something broader than policies that cannot be it could be achieved with policies, but where you don't want to allow yourself the possibility of misconfiguring a policy rule. In the case you have different persona handling the network and the policies at your company, because I think one of the critics to that network isolation would be that policies already allow something that akin to that. So we probably need to find some argument around that.
Yes, that's the main argument. And I think what exactly thank you, Nathan, for bringing this up, because that's exactly argument from everyone that you have network policies. And if it's even I heard recently that it's even compliant with some standard that requires isolation, and basically why it cannot apply to this. And I think what Doug brought up, the oversaturation of a link, is one of the reasons. Another reason, right? Because I cannot kill my management because I'm gonna just overkill the traffic, because I'm gonna generate the full capacity of the whole thing, right? So there are two things, right? So there is the isolation because of compliance, and then oversaturation of the link, right? And ensure we are not killing of the link to safeguard management or control plane.
So
Doug, would that be good? Will that be right? I think that's something.
Yeah, I think that's definitely a good way to put it. I think that it captures the gist, which is in the end, I think for performance reasons, you could have isolation for performance reasons.
So I think it's very easy to show that we need multi-networks and VRFs. The question is then, do you need to have multiple physical interfaces that you connect to? Basically, you need to have different, call it NICs, or do you build it with tunnels on top, or a combination of, right? And sort of, if we do so let's say that you only would have one physical interface, so you do everything with tunnels. That would still have to be then controlled by Kubernetes if you want to have network policies on them and so on. And you do all this work, and you have all the sort of problems with multi-homing that it comes with inside the pod. Why would you then restrict it to have sort of to just have logical tunnel-based interfaces on top of this ETH0 instead of being able to add many physical interfaces and tunnel interfaces if needed, right? So I think the need for multi-networking is quite straightforward to show how they're delivered, and if they should only be delivered over ETH0. I think it's also quite quick to come to the conclusion that it makes no sense to only have sort of one, call it way into the pod. Because you open up for many interfaces anyway, and then you have all the problems. So there might as
But
well.
I think that oversaturation is not something that you can avoid. You cannot overcome with one interface, right? You have to have separate
Yeah, no, it's like
interface.
so you can, of course, if you apply the right sort of
QoS.
QNS, but I mean, we all know what QNS does. It just creates complexity, and the way that's managed is by most network is to over provision.
That's fair. And I'm reading, Michael, as well to what you're saying. You could probably deal with that with some routing capability, right? But I get your gist on basically on the kind of user story. Yes, that's what we need to have, like proper user story written here. And maybe I will just paste it here so that I have that as a, because I'm trying to, what I'm thinking to kind of let's come up with some pointers for this, and then let's try to write down a meaningful stories as you had it, Michael. So I like that, and let's just do that. I'm saving your chat because this is good.
And that could be better. That was just like me putting it together.
Yeah, exactly. So because I do want to do that. I want what you just written. That's the form I want the stories to be created as. That's my goal of this whole effort that we're writing down. Because I want to have first the kind of some argument, some pointers for this, but then I want to write something exactly what you did, right? Exactly, because that should be the story that then is very visible and kind of speaks to everyone on that. Any other on the telecom stuff? So the other, I think we have 10 minutes, 8 minutes. The other thing I want to say is something that I started talking last on Thursday is the producer consumer story, where basically I probably need to some diagram, but this is something that we are thinking internally in our cloud to build. So a producer, basically I have some service, right? And I don't want to create thousands of clusters for my service to serve different projects, different tenants. Let's call them consumers is a tenant. Each tenant is its own entity. Think of it, everyone has its own organization, its own project. So basically there is completely unknown to each other tenants that has to be properly isolated, because you cannot mix and match, mix around customer traffic, right? So consumer is someone that's completely independent entities, and you want to in optimal way serve your service as a producer, right? So how you do that, right? How do you connect to a Kubernetes clusters, those different tenants, so that you don't mix their traffic, like don't completely isolate their traffic in such a way that there is no chance that it has to be even on a node level. Each node corresponds and handles only one tenant, right? So how you achieve that, right? How you interconnect things into those individual nodes from those other tenants, right? So that's my use case about I want to have multiple interfaces. I don't need and this is where the solution will be about, but I will describe it as such, right? Where I have a producer and consumer. The isolation has to be on a per node basis. The consumers cannot
Node or
mix.
pod? It's a
Say
pod
again?
it's a pod in reality, right? And now you're saying that you don't have dynamic way to provide networks to the node, so you fall down on that the node has the network. But it's really that you want the pods for this consumer to be connected to this unique network, right?
Yes, that's true. Yeah, to those
Yeah.
unique tenants. Yes.
So the
So
requirement,
that's
then the requirement to me is that it is the pod, and then there's an implementation follow requirement that says that it has to be already provisioned to the node. If it can be dynamically, it can
Yeah.
be pulled to the node.
so unique tenants. maybe I will say this, only one. Yeah. Is that clear, or that's a, because that's one of the, did I describe this correct? I probably have to massage it properly. But is this?
You want to have tenant specific networking. That's what you want to have.
Yeah.
And you
Yeah.
want for the pods that belongs to that tenant to be connected to the tenant's networks, and only to this tenant's networks, and other
Yeah.
tenants are connected to their networks.
Yeah.
So if that restricts it to a specific node or not is more the implementation of the platform, right?
Right.
Yeah.
Michael, I'm not sure who was first, but I will let you speak first.
Mine will be quick. I was wondering if it made sense to be a little bit more broad with node, as in like the confidential containers movement obviously is here. So a tenant could be, there could be a multi-tenant situation per node, assuming that the workload is isolated by its own kernel.
No. I would say no. You cannot. I'm so paranoid. It's one tenant per node. Even what you're saying, I hear what you're saying, but on kernel level, I say it's not even then. Should not be any chance that there are two nodes, or oh, you say by kernel because an underlying infrastructure. I see what you're saying. On
Yeah,
that
so
level,
like,
probably
yeah, if you have
probably
like
you're
Kata
right.
running, so you could actually
Because
have
you're
tenant
right.
A on one kernel, tenant 2 or B, whatever I just said. So it's really about the isolation here.
Yeah, thank you, because you just said in a different words what I said here, right? In a more
Again,
sophisticated.
if that's tied to that the kernel will know about the network. If the kernel wouldn't know about the network and it's provided directly up in the pod, would it then be okay to have different tenants on the same node? Or is it other resources as well, like looking into memory of the pods you're scared of? Just curious.
It depends. Yeah, because like right now, even in the cloud environment, you're isolated by, you know, the VM with the hypervisor. So
Yeah.
this is more specific to say that if we have a kernel running inside the VM guest, that could also be its individualized tenant.
So it can be, since pods doesn't have their own kernel, usually, I'm not sure whether you can achieve that, but let's assume kernel is shared on a pod level. That means a single node will have to be a per tenant. We have hands, and I think we're gonna, I think Nathan, go ahead.
My question was again on policies, playing the devil's advocate, but couldn't this be solved by policies again?
No, because this is what the second bullet says, right? Policies, you would make sure that kernel level traffic, you will have two tenants on a kernel level, even if they will be isolated by IP tables. You have two tenants, their traffic is on the same kernel. That's unacceptable.
Okay.
And basically, yeah, network policies kind of falls up, discards that.
Okay.
Michael, you want to say something more, or that's from previous? You had a hand. No? Okay. So we have 3 use cases that are really solid. More because we have 7 stories down there in our current 7 or 8 stories. What is the other real life user story that we would want to include this here? I think we can stop here. We have 1 minute, but let's continue this discussion to next week. Let's have this finalized before EU KubeCon so that we can go there. And Doug and Nathan, you can represent us with this, and we can even talk more on those use cases, so that you know what we want to achieve with this. All right, so that you have all the kind of angles of this when you're gonna discuss it in the workshop. Is that fair, Doug? Nathan?
Sure.
Okay. Sounds great. Okay, so I will try to reach out to my PM as well to kind of, because he has some use cases as well. I need to get some use cases from him so that we really kind of drill this further on and have some real stuff around this. So if you can come up with some other or expand on some of those, I look forward, and let's have a continuation of this discussion next week. Okay. All right. Let's stop here. Thanks, everyone.
All right, thank you. Bye.